The 3DuxDesign STEM Starter Challenge card deck includes 4 different projects, each designed as a low prep, team-based challenge that can be completed in one class period. This tutorial is for the Homes and Habitats activity, which you can find in the deck as the 10 cards with a green dotted perimeter. This project includes options to choose from 2 different levels based on the materials and the age group. Level 1 is a tech-free option where students use basic craft materials to plan and model how renewable energy would power their home. It's ideal for grades K through 8 and can be expected to be completed in one class period. The learning focuses on environmental studies, engineering design process, earth science, and architecture. If you're opting to do level 2 with your students, you will need the renewable energy kits along with the GoBox Classroom kit. This level is recommended for grades 3 and up and can be completed in 1 to 2 class periods. In addition to the level 1 learning goals, students will also be exploring basic circuits as they integrate real wind and solar power into their structural designs. In addition to the 3DuxDesign materials and your basic drafting tools, you will also need a light source, such as sunlight or a flashlight and a hair dryer. Be sure to test your flashlight ahead of time, as not all LED bulbs work well with the solar panels. A warm bulb generally works best with the 3DuxDesign solar kits. You may also wish to print some electrical circuit guides for each team. To begin the activity for either level, distribute cardboard pieces, connectors, and drafting materials to each team of 3 to 4 students. Give each team one Homes and Habitats Challenge card face down, and then read the script from the Homes and Habitats Mission Guide card to launch the challenge. Be sure to read the script that corresponds to your level. For level 1, you might allow 30 minutes for the build and 10 minutes for students to share. For level 2, the goal is to allow approximately 20 minutes for the structural build to leave time for the second part of the project. Each card includes key details about the local environment, including the climate, some natural resources, a local predator, and the likely renewable energy source needed. Students can use the image on the card as a guide or inspiration, along with these clues to guide their design. Homes should be intentionally designed to protect against the local weather, the featured predator, and teams can also build and decorate their structures to reflect the local building materials, such as wood beams, mud, ice blocks, or stone. For the level 1 group, the renewable energy source should similarly be depicted by drawing or in the building design. For level 2, offer teams a 3-minute warning as you distribute the renewable energy components. For the teams that will be needing the wind's power, the materials that should be distributed include the wind turbine and blades, assorted LED bulbs, 2 rubber bands that will be used for securing the turbines to the cardboard structure, copper tape, and/or alligator clips. For the teams that will be doing solar power, include the solar panels, assorted LED bulbs, copper tape, and alligator clips. Allow an additional 20 to 40 minutes for modeling, testing, and refining. If you're planning for 2 class periods, you can allow extra time for your teams to decorate their final structures. This can be done after the students are done optimizing their circuits and are able to successfully light their homes with the renewable energy materials. In your kits, you will also see on-off switches, which can be used to allow students to turn on and off their lights on their homes. But keep in mind, this does require extra time and some fine motor skills. This part of the project is designed to be open-ended, allowing students to explore the materials and figure out how to make the circuit work on their own. Although you may choose to share the next slides with your teams to help them get started. There is also a student booklet guide available if you would like to distribute that as well. Most importantly, remind students that LED light bulbs are directional. The long prong, or the positive side, must be connected to the positive side of the power source, or the red side. If connected backwards, it will not cause any damage, but the light will not turn on. For teams using the wind power, be sure to explain to your students that the hair dryer is strong and they should make sure to hold down their structure during the testing period. Feel free to print and distribute the student booklets or use the circuit slide deck with your students to introduce the basics of simple, parallel, and series circuits. In general, beyond the directionality, the power source can be connected much like any regular battery might be. For a simple circuit, students will be using only one bulb. For teams ready to take their designs further, they can experiment with more complex circuits using series and parallel connections. In the series circuit, voltage is shared across components, so you need enough total voltage to power all the LEDs. For example, two LEDs in series need more power than a single solar panel can provide in our case. The LED bulbs typically require 2 to 3 volts, and our solar power in the 3DuxDesign kits is approximately 3 to 5 volts. So unless you have an extremely bright light source, it is unlikely that in series the solar power will support both lights in series. We'll go over a little bit more detail about the different components in the 3DuxDesign renewable energy kit and their requirements in terms of power shortly. In the parallel circuit, each LED receives the full voltage from the power source, which often allows them to light more easily, even with lower voltage sources like a single solar panel. While the solar panels can provide only 3 to 5 volts, the wind turbines in your kit can generate up to 20 volts, allowing for students to run up to 4 bulbs in series successfully. Here is a schematic showing the relationship between the power source, the energy it provides, and the load in the circuit. The power source supplies energy. The wires can carry that energy, and the LEDs act as the load, using the energy to produce light. This helps students visualize how energy moves through the system and why different circuit setups change the outcome. For a nice literacy and tech extension, consider having your students present a real estate flyer using Canva, Google Slides, Book Creator, or other presentation tools. They should consider the buyer's perspective and be sure to include key selling details like the price, some unique features, like why it's perfect for the region and how it's sustainable and why that matters. You can add a math component using the Duxit ruler that's provided and having teams calculate the area and the cost per square Duxit of construction of the materials in their home. Your students can also use a variety of photography and videography apps, for example, making a commercial or using green screen technology to place their homes in a natural background environment. And this is an example of a book creator project done by another class of students. Another really fun tech extension might be to have your students use stop motion and create a short video describing their Monster Mountain feature in a video format. However you choose to use the 3DuxDesign STEM Starter Challenges, you and your students are in for a highly engaging, playful, and low prep STEM challenge that'll be perfect for the classroom, STEM lab, or even as a team STEM night challenge that the whole family can enjoy.